Hello viewers, in this video we'll go through Cambridge A-Level Further Mathematics Component 1, which is the Further Pure 1 paper. This is variant 3 from the May June 2025 series. We'll go and attempt question 4, I think question 4 in this video. The previous question is uploaded to the playlist. So question 4 is given you this product WR, which is kind of something like a factorial or permutation, something like that. And they want us to show that this product minus the r plus 1 minus r is this result. Okay, we want to prove this result. So I think first of all we go and write out what does this look like. What does the wr plus 1 look like? So wr is this, so we just replace all the r with r plus 1. So the first r becomes r plus 1, the second r plus 1 becomes r plus 2, and so on and so forth, right? So it becomes r plus 3, and all the way to r plus 10. Okay, because you have the additional 1 in there. Yeah, I'll go ahead and write here what is WR also. R plus 1, okay. And we go and try to, okay, we'll try to do the expansion for this WR plus 1. So if we let it be something like, I'm gonna rewrite this so that we have r plus 9 and then r plus 10. This is the same thing. I'm just rewriting it to include this r plus 9 term, so it's easier to visualize later. So what I'm going to do is I'm going to expand this in this way so that the r will multiply and then the 10 will also multiply. So this becomes two terms. Yeah, this becomes a addition of two terms. First we have the r plus 1, r plus 2, so on and so forth, r plus 9. Okay, and then we have the second term, which is 10 multiply r plus 1, r plus 2, and r plus 3, and so on and so forth until r plus 9. So this is all I've done is the expansion, right? And what we can notice here in this first term is basically what? This is basically the WR. And this term here, this is WR divided by R. Okay, so it's something similar. So maybe I can go ahead and rewrite this WR plus 1. That gives us WR. Then we have add 10 WR divided by R. Okay. So what do they want? WR plus 1 minus WR. Okay. So actually I don't think I should have rewritten this, but it's okay, we'll move forward. And so WR plus 1 minus WR, we can just go ahead and take away this WR, just get 10 WR divided by R, which will be 10 R plus 1, R plus 2, and so on and so forth until R plus 9. Okay, so this is part A. So we have shown this result. Now for part B, given that UR is this, we want to find the sum of UR from R equals to 1 to N. So, I mean, we can notice that UR is exactly the same as what we have proved just now, right? So, let me just rewrite also. UR is... Oh, actually, it's not the same because there's an additional 10 in front here. So, 10 UR, it will be equals to WR plus 1 minus WR. Right? This the only thing different, let me highlight here. This is the 10 in front. So, I will have the 10 here, right? And then... yeah, you are going to go and isolate it to become 1 over 10 WR plus 1 minus WR. So now we go and take the sum from R equals to 1, R equals to 1 to N, 1 over 10, and then WR plus 1 minus WR. So first of all, I will take the 110 outside of the summation, so it's to make it easier to see. So this is the summation that we're dealing with, WR plus 1 minus WR, and we can go ahead and try and simplify it by replacing 1 by 1 lah. Replacing 1 by 1, R equals to 1, and then up to maybe around 3, so it's to see if we can notice some type of pattern. So 1 over 10, when r equals to 1, so the first is r plus 1 will be w2, then wr will be w1. So this is when r equals to 1. So r equals to 2, so we have r plus 1 is 3, and so on and so forth, right? So w4 minus w3. And, in the middle here, we have a lot of other terms. Okay, let's say until n minus 1. So one term before n, we will have at wn minus wn minus 1. And finally, when it reaches n, it will become wn plus 1 minus wn. Okay, so this will be the whole, or this is the partial expansion. So we can try and see here, there is a pattern that something cancel out, right? W2 will cancel out by W2, W3, W3, W4 will be cancelled out by something inside, and so on and so forth. Wn will be cancelled, Wn minus 1 will be cancelled by something in here. Okay, so the only two things that is left after the cancellation, it will be Wn plus 1 and W1. Okay, so as we've proven before, we want it, okay, so we want it in terms of n. We'll just use this, the one that given in the question. Wr is this thing, so Wn plus 1, it will give us n plus 1, n plus 2, all the way until n plus 10, if I'm not mistaken, right? Yeah. And when r equals to 1 here, it would just be 1 times 2 times 3 until it times 10. So that will be just a 10 factorial. So minus 10 factorial. Okay, so now the whole thing is in terms of n, and yeah, we have answered the question. So we've found this summation in terms of n, purely n. Okay, part C. Now given that VR is this x power wr plus 1 minus xwr, find the set of values of x for which this infinite series is convergent, and give the sum to infinity with when this exists. Okay, so again, I think we need to substitute in the r value and see if we can get any pattern here. So v1, v2, v3, all the way to vn. Oh, sorry, it will go until infinity lah, but this will be, we'll represent it with n, which we can then kind of, so we have vn and then something like that. So yeah, vn is, let's say vn is a very very large term in the series, because this series is a infinite series and it doesn't end. So we just represent it. I mean, we will have a dot 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 to represent its infinite series. So we have x. Okay, when r is 1, we'll have xw2 minus xw1. R is 2. Okay, xw3 minus xw2. And again, so on and so forth until you have the n. Okay, so we have xwn plus 1 and xwn. And okay, in there should be a dot 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 in between here. So there are many other terms in between. And again, we have noticed the pattern where this w2 cancelled, w3 will be cancelled by something inside, wn also will be cancelled by something inside. So it's something similar, very similar to this part B here. In fact, almost the same. It's just now it's a raised to the power. Right, so all is left after the cancellation, it will be xwn plus 1 minus xw1. Okay, and we want to find the sum to infinity. Oh, sorry, we want to find, first of all, find the set of values of x for which this infinite series is convergent, and give the sum to infinity when this exists. So again, this is a exponential kind of thing. So let's recall the exponential behavior. Since this wn plus 1 is a very large number, right? So n itself is a very large number already, and since Wn is sort of a factorial thing, right? So something like this. So this let's say exponential, right? So anything power exponential a very large number, so this will not converge if x is not between 0 and 1, right? Because if x is larger than 1, so and n, again, n is a very large number. If x larger than 1, this term will blow up. Okay, this first term will blow up, and this second term also will it blow up? Because w1 is what? W1 is also a very big number, right? W1 is 10 factorial. So this term will also blow up. Um, yeah, it will blow up. So not convergent. It's divergent. When x is also when x is 0, does it have a, yeah, 0 power to a very large number is also um 0. So this one, it will converge, or it will converge to 0. Okay, then when x is between -1 and 1, I mean when x is between -1 and 1, because we know that when a number between this value is multiplied by itself, it will get a even smaller number, and when it's multiplied by itself to a magnitude of this, or wn plus 1, which is a very big number, this will essentially go 0, and the only term that will or significantly exist there, it will be the negative x power w1, right? So this, yeah, again, when x is in between these two values, this first term, it will go to a very small number, insignificant number, where the only significant number will be x power w1. Let me think. What else? When x equals to 1, so it'll be 0 also. Same, okay, same with x equals to -1, that will go to 0 also. So these are the, yeah, I believe these are the full answer to the values of x for which the sum to infinity exists and they converge, right? So yeah, that's part C, and we are done with this question. So thanks for watching.